This is SeaLaunch mission control. All systems are go at L-minus 26 minutes and 19 seconds.
MD, go ahead. PLU is go for launch. Roger, PLU is go for launch. We're all go for launch.
Spacecraft is confirmed go for launch.
We have engine ignition. We have liftoff on SeaLaunch. Main engine is at nominal thrust.
Payload preparing separation is confirmed. Ground track station has acquired the satellite.
Welcome to our live coverage of the Galaxy 19 mission. I'm Paula Korn, speaking to you from SeaLaunch Homeport in Long Beach, California. In 10 minutes, we'll be watching the liftoff of our fifth mission of the year from our equatorial launch site in the Pacific Ocean. As you can see, the launch vehicle is ready for liftoff from the Odyssey launch platform, positioned about 1,400 miles south of the Big Island of Hawaii. At the end of today's flight, this Zenit 3SL vehicle will place the Galaxy 19 satellite into a geosynchronous transfer orbit for Intelsat. Today's flight will take 63 minutes from liftoff to spacecraft separation. Operations are moving forward at the launch site, and all systems are looking good at this time. Liquid oxygen tanking is now completed. The thermostating hoses that supply cooling air for both the spacecraft and the rocket have been disconnected, and the erector arm is now lowering away from the rocket. When the erector arm gets down to the transporter below it, this transporter erector ground support structure will move inside its protective hangar for the remainder of launch operations. While this operation is underway, we have some welcoming remarks from Shell Carlson, President and General Manager of SeaLaunch.
Good morning, and welcome to all of you here today at our Homeport facilities in Long Beach. Thanks for joining us at this early hour. We're looking forward for launching another satellite for Intelsat, Galaxy 19. This will be our 8th satellite launch for our friends at Intelsat and our 9th satellite built by Space System Loral. I want to thank all the members of the combined teams, SeaLaunch, Intelsat, and Space System Loral, for their true dedication and professionalism in this mission. I'm pleased to report at this time all systems are go at the launch site, all ready for an on-time launch at 2:28 a.m. this morning. Thank you once again for joining us this morning, and sit back and enjoy the mission coverage.
And that was Shell Carlson, President and General Manager of SeaLaunch. We recorded his remarks a few minutes ago for today's mission coverage. And you're watching live coverage of the launch of the Galaxy 19 satellite. We're looking at a Zenit 3SL rocket ready for liftoff from the Odyssey launch platform, positioned at 154 degrees west longitude on the equator. We're launching a satellite for Intelsat today. It was built by Space Systems Loral and carries a total of 52 transponders. The 1300 series hybrid spacecraft accommodates a wide range of satellite services and has an excellent record of reliable operation. Its high-efficiency solar arrays and lightweight batteries are designed to provide uninterrupted electrical power. Once in orbit, the Galaxy 19 satellite will be located at 97 degrees west longitude. It will provide Intelsat customers with coverage over all of the United States, Canada, Mexico, and the Caribbean islands. Intelsat is the leading provider of fixed satellite services worldwide, delivering advanced transmission access for information and entertainment to many of the world's leading media and network companies, multinational corporations, internet service providers, and governmental agencies. Intelsat also offers seamless service for voice, data, and video transmission. At 7.5 minutes and counting, all systems are looking good for an on-time liftoff at 9:28 Greenwich Mean Time. Let's take a look at today's mission profile. A Zenit 3SL vehicle will lift off from the launch pad on the Odyssey launch platform, carrying the Galaxy 19 satellite, which weighs 4,690 kilograms, or 10,316 pounds. 2.5 minutes after liftoff, the first stage, and then the payload fairing, will jettison. 6 minutes later, the second stage will separate from the Block DM upper stage. After an 8.5 minute burn of the Block DM, the spacecraft will coast for a half hour in a parking orbit. Following this coast period, the Block DM will execute a second burn, this time for just 3 minutes, and then coast again. This 10-minute coast will prepare for a spacecraft separation near the west coast of Africa. Operators at the Hartebeestok ground station in South Africa will be tracking the spacecraft to acquire its first signals in orbit soon after separating from the upper stage. The Galaxy 19 satellite will be positioned at 97 degrees west longitude. And that's what our flight plan looks like for today, and our countdown continues. We're coming up on 5.5 minutes to liftoff now. Looks like a beautiful night out there on the equator. The team in the Launch Control Center is progressing through the final countdown procedure at this time. They're monitoring telemetry from the launch vehicle and the spacecraft to ensure all critical systems are nominal for launch. The Launch Control Center is located on the SeaLaunch Commander, now safely positioned about 3.5 miles from the launch platform. All personnel are aboard the ship, and our marine crew is operating the launch platform remotely from the captain's bridge. The team is keeping an eye on both of the vessels as well as the launch range to make sure all conditions are within our launch criteria. The marine crews verify and hold the relative headings of the vessels to ensure their exact orientation. The launch platform maintains a position that's optimal for the launch trajectory and minimizes the loads on the vehicle. SeaLaunch monitors sea conditions in real time using our own buoy near the launch location, and we also monitor winds aloft by releasing weather balloons like this one at specific intervals prior to launch. We want to take this opportunity to extend a warm welcome to our formidable guests here at Homeport who have ventured out in the middle of the night to join us for this event. It's several hours before dawn here in Long Beach, California. We also want to welcome our friends at Intelsat watching our coverage in Washington, D.C., and the team at Space Systems Loral to the north of us in Palo Alto, California. And of course, we want to welcome all of our viewers who are joining us on our live satellite feed or our simultaneous webcast all around the world. We're coming up on a 3-minute status from the Launch Control Center, so we'll listen in for that report now.
SMM, MD on channel 1.
Go ahead.
Yes, sir. All systems are go for launch.
Roger that. Go G19, or shall we say Intelsat Americas 9.
And we were hearing Jim Mills, our mission director for today's flight, confirming all systems are go for launch as the countdown continues. The weather for today's launch is good, and at this time all environmental conditions continue to be within our launch criteria. The current temperature at the launch site is 80 degrees Fahrenheit, with winds from the southeast at 9.7 knots. Seas are running 6 feet from the east-southeast. And we're at 2 minutes to launch now, and all mission milestones are proceeding on schedule. The teams from SeaLaunch and Space Systems Loral are making their final assessments now before the terminal count begins. Always an exciting moment here to see this rocket sitting on the platform in the middle of the sea. And at 1 minute and counting now, we are go for launch of the Galaxy 19 satellite. We will stand by for the terminal count, which you'll be hearing in both Russian and in English.
Stand by for the terminal count.
Последние секунды предстартового отсчета.
10,
10,
9,
9,
8,
8,
7,
7,
6,
6,
5,
5,
4,
4,
main
3,
engine start,
2,
1,
go
inertial, liftoff. Main engine is at nominal thrust. Begin pitch over. ILV stabilization is nominal.
Go ahead.
Propulsion system performance is nominal.
Confirmed.
Roger.
Принял.
Flight is nominal. ILV stabilization is nominal. ILV is now transonic. Main engine pressure is nominal. Flight is nominal. Maximum dynamic pressure. ILV stabilization is nominal.
MDRSOM.
Go ahead.
Слушаю.
Точное время КП по Гринвичу 9 часов 27 минут 59,108 тысячных секунды.
Contact liftoff occurred at 09:27:59
Contact liftoff time was
UTC.
9 hours,
Roger.
27 minutes, 59,108. Propulsion system performance is nominal. Flight is nominal. ILV motion is stable. Begin engine throttling from minimum acceleration. Flight is nominal. ILV stabilization is nominal. Final sequence of throttling. Flight is nominal. Second stage vernier engine ignition. First stage engine shutdown. First stage separation. Second stage main engine ignition command is issued. Main engine nominal throttle up. ILV stabilization is nominal. Main and vernier engine pressure is nominal.
OSS MD on 1. This is OSS. Go
ILV
ahead.
flight
Roger,
is
begin
nominal.
aerial inspection of the LP. Roger.
ILV motion is stable. Main engine vernier engine pressure is nominal. Flight is nominal.
During separation,
Tail
brake
jettison
wires
command
confirmed.
is
Директор
sent.
миссии РС.
MDRSOM.
Go ahead, sir.
Слушаю вас.
Идет приведение ракетного сегмента в исходное состояние.
Rocket segment is returning systems to the initial state.
Roger.
Принял.
ILV motion is stable.
Brewster Ground Station confirms receipt of Block DM and PLU telemetry on TDRS 171.
Main and vernier engine pressure is nominal. ILV flight is nominal.
And we are now 4.5 minutes into the flight of the Galaxy 19 satellite. We have confirmation of first stage separation and successful jettison of the payload fairing. The telemetry for the Zenit 3SL launch vehicle is looking good. The second stage engine will burn now for 6 minutes, traveling above the atmosphere, and then it will separate from the Block DM upper stage. During this phase of flight, we'll hear announcements for the operation of the second stage main engine and the throttling down of this engine. And this reduction in thrust allows for a safe shutdown of the main engine.
Pressure in main and vernier engine is nominal. ILV flight is nominal. ILV motion is stable. Main and vernier engine performance is nominal. ILV stabilization is nominal. ILV axial load is nominal. ILV flight is nominal. Begin second stage throttle down. Flight is nominal. Second stage main engine shutdown confirmed.
ACS ground confirms receipt of TDRS PLU telemetry.
Pressure in vernier engine is nominal. ILV axial load is nominal. Vernier engine performance is nominal. Flight is nominal. ILV axial load is nominal. Vernier engine pressure is nominal. Second stage vernier engine shutdown is confirmed. Zenith block DM separation is confirmed. Axial settling thruster ignition is confirmed. Block DM sleeve adapter jettison is confirmed. Low gain antenna deployed. First block DM main engine start is confirmed. Block DM main engine pressure is nominal. Zenith block DM separation occurred at 9 hours 36 minutes 23 seconds GMT. Block DM first burn ignition time was 9 hours 36 minutes 33 seconds UTC. Block DM stabilization is nominal. Main engine pressure is nominal. Block DM flight is nominal. Moscow Mission Control Center reports all Block DM systems are performing nominally.
And as you've heard, we have confirmation that the second stage has jettisoned and the Block DM main engine is now in operation for 8.5 minutes. The first burn of the Block DM upper stage boosts the spacecraft into a stable parking orbit. Let's take a minute here to look at that liftoff we saw just 10 minutes ago.
10,
10,
9,
9,
8,
8,
7,
7,
6,
6,
5,
5,
4,
4, main engine start,
2,
1, go
1.
inertial, liftoff. Main engine is at nominal thrust. Begin pitch over. ILV stabilization is nominal.
MDRSOM.
Go ahead.
Propulsion system performance is nominal.
Liftoff is confirmed.
Roger.
Принял. Flight is nominal. ILV stabilization is nominal.
And that was a replay of our Zenit 3SL rocket lifting off from the Odyssey launch platform it is about 11 minutes ago now. And we didn't get as much visible ascent as we like to see, but it was beautiful lifting off. Great launch. The Block DM is now accelerating with the Galaxy 19 satellite at an altitude of about 108 miles or 174 kilometers. And is now almost 1,800 miles downrange from the launch platform. Here's a video about the Galaxy 19 satellite, now in flight.
Everybody is really excited about this new Galaxy satellite that we're going to be adding to our fleet. a good team, a good staff, good engineers, good employees at the company, and great relationships with the customers what made Galaxy 19 successful.
Galaxy 19 is the 43rd satellite that we delivered to Intelsat, and it's certainly an excellent testimony of our relationship with the Intelsat customer.
Galaxy 19 was originally designed to go in both 97 degree west and 129 degree west. It is currently destined for the 97 degree west slot, but it can also serve the market in 129 degree west if it needed to be moved to that orbital slot.
The Galaxy 19 satellite will be used for a variety of applications: video services, occasional use video, corporate networking, and internet trunking. Once into service, the satellite will provide 24 C-band and 24 Ku band, equivalent 36 MHz transponders to our North American customers. The satellite will cover continental U.S., Hawaii, Puerto Rico, Mexico, and even the southern part of Canada.
One big part of the successful program was ensuring the teamwork, and we worked with the customer Intelsat to produce a satellite on a relatively short schedule from what they're used to. It was a 26-month program. SSL and Intelsat have a long-standing relationship going back to Intelsat 5, Intelsat 7 series, Intelsat 9. It continued through the Pan Amsat satellites and with the merger.
The relationship and the nature of the relationship goes well beyond the numbers. It actually is based on mutual respect. It's based on our continuous effort to support the Intelsat business throughout the years. And it's also based on our common teams here in Palo Alto who always strive for the best quality and the best reliability within the programmatic requirements.
Through the last 30 years, both our companies have grown together, and we learned to work together in a very efficient manner. The Intelsat local team, who does the monitoring of the spacecraft, as well as the Space Systems Loral program office team, were able to work in a very close cooperation on a daily basis, and that eventually resulted in a very high quality and a very good, reliable satellite.
Galaxy 19 is the 5th satellite that we deliver this year. I'm particularly proud of this achievement, which certainly shows the dedication and the hard work not only of our teams, but also our teams together with the Intelsat customer in this particular case.
One of the key successes of the program is the people, and not only the people, but all the friends and family behind the people working on the program. I'd like to thank all the Loral employees and all the family to support them to the long hours to deliver a very quality product on time to a great and successful customer.
Galaxy 19 is the third launch that we have this year with SeaLaunch. We're particularly happy and proud to continue our collaboration with SeaLaunch for yet another very successful launch.
I would like to take the opportunity to thank my colleague at SeaLaunch, Space Systems Loral, and Intelsat who worked very hard on this program. So Galaxy 19, go for launch!
And we're back live to our live coverage here of Galaxy 19, and we're coming up on the end of the first burn of the Block DM upper stage.
First Block DM main engine shut down. First Block DM main engine shutdown time was 9 hours, 44 minutes, 56 seconds GMT.
AMD copies and concurs.
The Block DM will coast until 10 hours, 17 minutes, 58 seconds UTC.
Brewster Ground Station confirms planned loss of telemetry on T-10mins 171.
And we've just learned that the first operation of the Block DM upper stage was completed successfully. The Galaxy 19 satellite and the upper stage are now coasting in a stable parking orbit for a half-hour period, after which the Block DM engine will ignite for a second time. SeaLaunch uses the reliable Block DM upper stage on all of its missions. Like the first and second stages of the Zenit booster, the Block DM upper stage also uses a clean mix of liquid oxygen and kerosene as propellant. Our Russian partner, RSC Energia, builds and operates this stage of the rocket. The Block DM we use, called the Block DM SL, was specifically designed for SeaLaunch operations and has provided excellent performance. During this coast period, mission managers will be observing the onboard systems of the Block DM and the Galaxy 19 satellite as the upper stage and the spacecraft coast over the equator. The team will be monitoring telemetry in the Launch Control Center and at the launch site and at support centers in Moscow and Seattle. Also at the launch site, the SeaLaunch helicopter, now in the process of making an aerial inspection of the launch platform, and will soon transport a red team to the platform for a closer safety inspection and securing of the vessel. They will make sure it's safe for people to return to the platform, and then about 6 hours from now, personnel will start returning to the platform for their post-launch operations. We'll return to our live coverage of the flight of Galaxy 19 after these remarks from David McClade, CEO of Intelsat.
Hello, everyone. The entire Intelsat team is looking forward to today's Galaxy 19 mission. This is our last launch of the year, continuing our fleet upgrade initiative. Galaxy 19 will replace our Galaxy 25 spacecraft located 97 degrees west. This satellite will provide our customers valuable 50-state coverage, in addition to reaching the Caribbean, Canada, and Mexico. Once operational, Galaxy 19 will host one of the largest international video programming platforms in the region. In fact, globalization of content continues to be a significant driver for industry growth, creating demand for satellite capacity. Because of the global society we live in today, being able to watch regional programming from other countries or special events such as the Olympic Games remains paramount, especially for the ethnically diverse audience of North America. Intelsat's Galaxy 19 satellite will provide premier coverage for programmers seeking to disseminate international content throughout this region. After today's launch, we look forward to introducing 5 more satellites into our fleet over the next 3 years. These programs are progressing as planned, and we are on track with our $460 to $500 million investment commitment for 2008. With that, I would like to thank Space Systems Loral and SeaLaunch for all their hard work on today's mission. Galaxy 19 marks our 8th mission with SeaLaunch and is the 43rd satellite constructed by SS Loral to enter our fleet. Lastly, to our Intelsat employees involved with this satellite and launch campaign, I thank you as well for your continued dedication to our fleet upgrade campaigns. Thank you for your efforts and good work.
And welcome back to our live coverage of the flight of Galaxy 19. At over 21 minutes now into this mission, the Block DM upper stage and the Galaxy 19 satellite are coasting in a parking orbit. The Block DM has successfully completed the first of 2 burns, injecting the satellite into a stable parking orbit. The use of the parking orbit, followed by the second burn, allows us to deliver the spacecraft to a higher orbital perigee height, which translates into a longer spacecraft lifetime. The SeaLaunch mission design process is very flexible and allows each spacecraft we launch to take full advantage of the Zenit 3SL's heavy lift capability. SeaLaunch works with each of our customers during mission integration to optimize the orbital injection conditions to best suit the needs of each spacecraft. Galaxy 19 and the Block DM are now traveling in an easterly direction, taking the equatorial route across the Pacific Ocean toward South America, as you can see here on this map. And now what we're seeing is an animation of the flight design for this mission. We're looking at a high-speed, 1-minute version of this 1-hour mission. And that's what rocket science is all about. And while this mission is underway, let's go back to the preparations at home port that led up to today's flight. Space Systems Loral delivered the Galaxy 19 satellite to SeaLaunch home port in mid-July. The spacecraft was brought to SeaLaunch's payload processing facility, where it was tested, fueled, and encapsulated in a payload fairing. In September, the payload team transferred the encapsulated spacecraft in what we call the payload unit from the payload processing facility to the SeaLaunch commander, where it was mated with the upper stage of a Zenit 3SL launch vehicle. The fully integrated launch vehicle was transferred from the ship to the Odyssey launch platform. Then the rocket was rolled out of its protective hangar and erected on the launch pad. In its vertical position, the rocket was put through a series of mechanical and electrical tests that verified all systems were in order. At the conclusion of these tests, the rocket was lowered to its horizontal position, returned to the hangar, and prepared for transit to the launch site on the equator. The launch platform departed home port on September 8th. The SeaLaunch commander followed on September 10th, and then the two vessels rendezvoused at sea and began operations at the launch site at 154 degrees west longitude. The team ballasted the launch platform about 65 feet to its launch depth, and the launch countdown was initiated at L-72 hours. A day before launch, the rocket was rolled out and erected to a vertical position on the launch pad. After final tests and then fueling, the SeaLaunch system was ready for today's launch. And that's a brief look at some of the operations at home port that brought us to where we are in today's mission. And it represents a lot of planning, logistics, and expertise. And now, at 25.5 minutes into this mission, we're in the midst of our coast period with the Block DM upper stage and the Galaxy 19 satellite heading toward the Atlantic Ocean, traveling directly over the equator, as we're seeing on our tracking map here. They're moving at a speed of more than 19,000 miles per hour, taking the satellite to an optimum position to begin the second burn of the Block DM upper stage. Our team in the Launch Control Center at the equator is reporting that all systems are nominal. We had an opportunity to chat with a few of the managers from Intelsat and Space Systems Loral during a recent visit to home port before the vessels departed. Let's listen to what they had to say.
I've been involved with SeaLaunch as part of either the spacecraft team or part of the launch services team So this time I'm acting as the program manager for launch services for Galaxy 19. I'm here when the spacecraft arrives on the very first day of the campaign. That's about almost 60 days prior to the launch. I'm here when the satellite arrives, and in this case Galaxy 19 is built by Loral in Palo Alto. So when it arrived, I was here. I've been here when the satellite had all the standalone testing, and then when the satellite was being fueled, I was here to make sure that all the operations were continuing nominally. And when the satellite was integrated onto the SeaLaunch adapter, we were here to make sure that all those operations were completed nominally.
Yeah, I'm Grant Gould, manager of the Launch Systems Department at Space Systems Loral. As manager of the department, I'm involved in all of our launch integration activities and the operations. I'm down here supporting this Galaxy 19 spacecraft for our Intelsat customer. Most people only see the work here at Homeport as our satellite arrives and we prepare it for launch. But this is just really the tip of the iceberg. Our activities start well in advance of our arrival here at Homeport. We work with the SeaLaunch program management team and the mission integration team, making sure that our LS-1300 spacecraft is fully compatible with the SeaLaunch launch service.
My name's Bill Weller. I'm Vice President of Marketing and Sales at Space Systems Loral, and I'm responsible for working with Intelsat at the beginning of our programs to understand their requirements and make sure that we give them the best value, design, and capability that can be provided. And then during the program, I'm responsible for making sure that the Intelsat interests are represented on the program all the way through delivery and on-orbit support during the lifetime of the satellite.
My name is Mohinder Guru. I'm a senior manager based in Palo Alto, California, in the role of monitoring satellite procurement and build, currently obviously at SSL. I'll be supporting the complete launch of Galaxy 19, so I'll be going on the ship. This will be my first experience with SeaLaunch. However, I have been here on a number of times supporting just the home port operations, integrating the satellite to the launch vehicle, etc. So I'm looking forward to this experience, actually.
Toby Nassif, Vice President of Space Operations and Engineering for Intelsat. My relation with the Galaxy 19 mission is that we'll actually be conducting the mission once the spacecraft separates from the rocket, doing the mission, do the orbit raising, as well as then the in-orbit testing, and then also the long-term operations of Galaxy 19. So I've come to know SeaLaunch pretty well. It's a great system. The launcher taking it down the equator and launch right there, cutting out most of the inclination, giving us longer fuel life on orbit. It's really neat. And as a former naval officer, used to go out to sea, I think it's a pretty cool concept.
I think the reason why our campaign has gone along so well is because of we've worked with Loral many times. This is, like I mentioned, their 8th campaign with you, and the experience level of SeaLaunch and Loral has been excellent, and this just makes for a perfect campaign.
This is going to be my first launch I'll be experiencing where I'll actually see the rocket launch with one of our own satellites. Prior to that, I've been to Kazakhstan on Baikonur for the Proton launch. I've been to French Guiana many a times, and I've never actually seen a launch because I was there for the first half of the campaign. So this will be. That's why I'm very much looking forward to this experience.
For the long-term operations of a spacecraft, what we do is basically we take care of the satellite. Our satellite engineers, or sometimes I call them the satellite doctors, make sure the satellites stay healthy, they operate as expected, and they keep the payload on for our customers.
I'll be in complete communication with the team back in Washington, D.C., and give them a verbal when everybody's satisfied that the spacecraft is ready to go onto internal power. That means that the spacecraft is all ready to go.
I guess one of the most interesting aspects of this spacecraft for me in the Launch Systems Department is this is our 8th SeaLaunch mission, our 3rd of this year. I have the best job at SSL. I get to work with all the launch service providers, foreign and domestic. I get to travel to exotic locations, and then in the end, we launch an LS-1300 on a launch vehicle. It's a very rewarding position. We leave no stone unturned in the mission integration process. It's a very detailed process. We go through the critical clearances, the loads, separation dynamics, mission design. Nothing is left to chance when we launch one of our spacecraft.
As I mentioned, the SeaLaunch is one of the unique launches in the world, as it actually uses a marine segment and a land-based segment. So it's unique in that sense. Many of the launch locations are typically in very remote locations that take 2 or 3 days to get there. One of the great things about this location is it's about half an hour from my home because I'm based in the Long Beach Intelsat office.
As evidenced by the number of times that we launch on SeaLaunch, we have an excellent relationship working with SeaLaunch, and in particular, the geographic proximity to the Bay Area makes it very easy for us, as well as the people, being that they're close and we've worked with them many times, we get a real familiarity with working with SeaLaunch. And on the Galaxy 19 program, this satellite also will add to the industry-leading number of transponders that we have of our satellites that are on orbit right now. So it's been a very pleasurable launch campaign, I understand, and we're looking forward to a successful mission.
Working with the SeaLaunch team is really great. We've always found their program management team, mission integration team, the ops folks to be the utmost professionals, competent but yet flexible. Let's face it, taking one of our LS-1300 spacecraft and integrating it onto any launch vehicle, including SeaLaunch, it's a marriage of our requirements and capabilities with the launch vehicle's requirements and capabilities. And as this is our 8th launch, I'm happy to report that we have a pretty successful marriage.
Well, other than going to sea and launching directly on the equator, I think the real significant difference between other launch providers is its international nature of the launch team, again being a mix of the Russians, Norwegians, and U.S. personnel. You don't see that with other launchers. They're all either one nationality, whether it's Russian, French, or U.S. So that's a unique characteristic. And again, the other big one is taking it out to the equator, where you really get the best performance from a launch vehicle.
Well, the first thing that I will say that distinguishes SeaLaunch is the weather that we have down here at Homeport. And at the launch, what you would call, many people would call the launch base, where you launch out in the tropics, where it is just beautiful, I understand. I've not had the opportunity, but if I ever do, I think I would jump at the opportunity to go out on a launch. The people working with the people from SeaLaunch has always been a wonderful experience, from the management, from working with Shell and the sales team and the mission manager, Terry Bolin. It's always been a very pleasurable experience working with the SeaLaunch team.
I would like to thank, obviously, Space Systems Loral for doing an excellent job in the constrained time span we had. Obviously, SeaLaunch for doing a wonderful job in getting the spacecraft integrated into the launch vehicle. And now we just go hoping for a successful G19 launch.
I'd like to thank the whole SeaLaunch team, and all of its partners and players to get to where we've gotten so far in getting G19 ready for launch.
I'd like to say that I'm very pleased once again to work with the SeaLaunch team and the Loral team, and it's been a great experience here working with the team once again.
Hey, go Galaxy, go SeaLaunch, go Loral.
And welcome back to our live coverage. And we're now almost 36 minutes into the Galaxy 19 mission. The launch team is monitoring the Block DM and Galaxy 19 satellite during this 30-minute coast period, and they're reporting that all operations are performing as planned. The upper stage and the satellite are now traveling about 1,500 miles above the equator at more than 16,000 miles an hour. And we'll be back after this message from Intelsat.
In 1965, Intelsat launched the first commercial communications satellite.
Today, we are the leading provider of fixed satellite services worldwide, with approximately 300 antennas and 8 Intelsat-operated teleports, over 20,000 miles of fiber, and points of presence in 9 cities.
Our fleet covers 99% of the world's populated regions.
We serve many of the world's leading media and communications companies.
multinational corporations, regional data networking customers, and the government sector.
Intelsat provides seamless, secure, and easy access to information and entertainment on land and sea.
Customers depend on our global network, technical leadership, and commercial innovation to better serve their customers.
Intelsat's history is all about innovation.
Tranquility Base here. The Eagle has landed. That's one small step for man, one giant leap for mankind. Roger. Well done, Tom. It was a good show.
This is where HDTV enters the picture.
Democracy and freedom for all.
Intelsat CMC, may I help you? Is that okay now?
This is an important launch. We're proud of the event, and we're proud of all of you.
Today, we are making history together.
As Intelsat launches future state-of-the-art satellites, we increase our expertise, experience, and capabilities to support the evolving universe of satellite services.
Satellite operators look to Intelsat for acquisition, program management, launch, and in-orbit operations.
Intelsat offers the most comprehensive distribution network in the world, using the latest integrated service technologies.
We're fueling next-generation growth of HDTV, IPTV direct-to-home distribution, ethnic programming, broadband, and VSAT solutions.
Our primary focus is serving customers and delivering innovation to allow your business communications to work with the speed of the future. Contact Intelsat and we'll show you how we can work for you.
Intelsat, connecting planet Earth.
And we'd like to thank Intelsat for that beautiful video and also for their support in today's satellite transmission of our mission coverage. And we're now a little over 40 minutes into the Galaxy 19 mission. The launch team continues to monitor the Block DM upper stage and the Galaxy 19 satellite as they coast in a parking orbit over the equator. All operations are performing as expected. And with another 10 minutes left in this coast period, we'd like to feature some of the people behind today's mission who make it all possible. And that's the team behind the mission, and every individual is amazing. We want to thank our photographers, Dave Hutzel and Larry Trotter, for the great work they did in capturing all those images. And we're coming to the end of the coast period now. The Block DM and the Galaxy 19 satellite are coasting over the Atlantic Ocean, approaching the coast of Africa at the equator, as you see on the map here. And the team in the Launch Control Center is reporting that all systems continue to operate as planned as we approach the second burn of the Block DM upper stage. Let's listen for that now.
Second Block DM main engine start confirmed. Block DM second burn start time was 10 hours, 18 minutes, 00 seconds, UTC.
And we have confirmation, as you just heard, that the second burn of the Block DM upper stage is now in operation. This 3-minute burn will inject the Block DM upper stage and the Galaxy 19 satellite into geosynchronous transfer orbit. Earlier in today's launch coverage, we described today's flight profile. Let's take another look at the animation we saw as we approach our next milestone event.
Mission Control Center in Moscow reports our Block DM systems are operating nominally. Main engine pressure is nominal.
And we're returning to the Launch Control Center for the latest word on the end of the second burn of the Block DM upper stage. It's about a 3-minute burn. And we should be expecting that in about 30 seconds.
Block DM flight is nominal. Block DM burn 2 shutdown confirmed. Block DM second burn shutdown time was 10 hours, 21 minutes, 05 seconds, UTC. Block DM flight is nominal.
And with the Block DM's second operation now completed exactly on time, the upper stage will begin maneuvers in preparation for the spacecraft separation during this next 10-minute coast period. And we'll be back with our live coverage of the mission of Galaxy 19 right after this message from our spacecraft manufacturer, Space Systems Loral.
Orbiting more than 20,000 miles above Earth's surface, a myriad of satellites built by Space Systems Loral provide essential communication services to people all over the world. The company's satellites are used for everything from forecasting the weather to the delivery of video programming to small handheld devices. As the world leader in the design and manufacture of high-power commercial satellites, SSL maintains a long-term commitment to its customers, from initial design through a satellite's 15-year life and longer. The experts at SSL have a passion for helping both new and established satellite operators build spacecraft with the flexibility to meet evolving market requirements. They take a strategic approach, bringing many years of experience and a deep understanding of how satellite-based infrastructure can help companies meet their business objectives. SSL's evolutionary approach to satellite design provides customers with innovative and sophisticated solutions while ensuring high reliability and continuous service. It is with committed leadership that SSL advances in an industry where customers demand unfailing reliability and a vision into future possibilities. Under the dedicated leadership of CEO Patrick DeWitt, Space Systems Loral and its employees achieve success, both for the company and for its customers.
And we're now approaching spacecraft separation, our next milestone. And at this point in the mission, the Block DM will reorient itself into the proper pointing position for the separation process. Here's how this process works. The attitude control system stabilizes the Block DM upper stage on the spacecraft. The Block DM then issues a separation command to the payload adapter. For this mission, we're using the low-shock 1194 VS clamp band separation system built for SeaLaunch by Saab Space, which was recently acquired by the RUAG Technology Group. The Space Systems Loral 1300 series spacecraft is designed to separate with a slight tip-off technique, initiated by non-symmetrical separation springs. As the Block DM and the spacecraft separate, the separation system springs will impart a lateral rotation to the spacecraft. This will be the 401st separation of this system. Saab Space began its technology development for separation systems in 1978, and today they have 3 decades of experience, and they are the leading supplier for adapters and separation systems for launchers. Saab Space has a modular adapter concept that enables fitting any commercial satellite to most commercially available launchers. As a result, satellites can be moved from one launcher to another on short notice in case of logistical issues. Now, under the new name of RUAG Aerospace Sweden, AB, this Swedish company has solutions to meet every adapter and separation system requirement and continues to supply reliable separation system products to the launch systems around the world. We want to congratulate the team from RUAG Aerospace Sweden for 30 years of significant achievements and 400 successful missions and separations, and many of them with the SeaLaunch system. At 57 minutes into the flight of the Galaxy 19 satellite, members of the launch team are monitoring telemetry from the onboard systems of the Block DM upper stage and the satellite, now coasting together in geosynchronous transfer orbit over the equatorial Atlantic near the west coast of Africa. As we approach spacecraft separation, let's learn a bit more about this event from our Galaxy 19 mission manager, Terry Boland. Terry, you've worked on many missions before here at SeaLaunch, but before we talk about this upcoming spacecraft separation milestone, tell me a little bit about what it means to be a mission manager and what are the roles and responsibilities?
Sure, Paula. First of all, mission manager is actually a pretty exciting job. We start from the beginning of a contract up through launch and actually with completion of all the paperwork, post-flight reports afterwards. So overall, I have a responsibility for the overall contract execution, but really we focus on the technical analysis to assure that the spacecraft and the launch system are compatible with each other.
So you're sort of the middleman between the spacecraft and the customer, as well as the SeaLaunch system?
Essentially, yes. Yes, it worked with a very capable team up north with the folks from Seattle and the Boeing folks up there, and they take care of the detailed engineering. But I'm here overall to coordinate any programmatic issues, assure various things get done, and address issues as they come up.
And what was it like working on Galaxy 19? Any particular highlights?
Well, overall, this integration was pure pleasure. It showed the maturity of working not only with Intelsat, but Space Systems Loral is a good, real team camaraderie developed to really solve problems, which we really didn't have any particular problems because it ran smooth based on our experience. So the highlights were that it ran overall very smooth. And of course, the biggest highlights was when the spacecraft comes through the gate. It was delivered.
And now we're coming up to a major highlight of this mission, spacecraft separation. So tell us a little bit about that relative to the spacecraft and the responsibilities of the players, SeaLaunch and Space Systems Loral and Intelsat.
Spacecraft separation really represents the delivery of the spacecraft for our launch service contract. You know, we separate it from the upper stage, we point it in the right direction, give it the right velocity at the right altitude. It's very exciting. As you know, of course, all happens automatically by the launch vehicle itself. As soon as we spacecraft, we get confirmation of separation. Essentially, Loral, in this case, takes over, or I believe Intelsat's also controlling this, takes over the spacecraft and begins their work really begins. The launch vehicle side is pretty much complete.
Once we separate it
and deliver it to orbit. Right, and deliver it to orbit.
And then Intelsat will take over it and begin the deployment and moving it to its final orbit. Is that right?
They'll do some initial checks and then begin their various, like solar array deployment, for example, and do health checks, communicate with it, and make sure it's in good shape and begin operating from there.
And is there anything of a particular nature on this mission relative to the spacecraft system, the separation system?
This, nothing particular. This is a pretty much heritage system. It's been used, in fact, on all of the Loral missions that SeaLaunch has had. Very flight proven. There's nothing new, nothing exotic. Pretty much a standard Loral separation sequence with this also.
And as we said earlier, this is around the 400 separation of this space separation system. So I guess it's tried and true.
Very tried and true.
Nothing to worry about.
Yes, that's right. But you wait for that call out and all the indications sent back that everything's okay.
So when we have spacecraft separation, is that your final breath of relief from your end?
It's a big breathing sigh of relief, but really we're looking for spacecraft acquisition. Because that's really tells us that the spacecraft was, that initial check that was delivered just fine, and they're talking to it and starting to work with it. So really the sigh of relief at this point is spacecraft to acquire the spacecraft.
Right. Well, that'll be coming up shortly. And Terry, I'm so glad you're able to stop by in our studio today. Thank you so much, and we'll talk with you when the mission is over at the other end.
Very much, Paul. My pleasure.
Thanks a lot.
Thank you.
And we're monitoring live audio from the Launch Control Center on the SeaLaunch Commander for word of spacecraft separation. The Galaxy 19 satellite will be separating from the Block DM upper stage within the next couple of minutes.
ACS confirms Block DM spacecraft separation. Spacecraft separation time was 10 hours, 30 minutes, 54 seconds UTC.
And as you just heard, with all the applause, we have confirmation of spacecraft separation, marking the 401st successful separation of the subspace separation system. And now that the spacecraft has separated and is coasting independently, it is moving away from the Block DM upper stage. The Block DM performs a set of maneuvers to distance itself from the spacecraft to avoid any recontact or contamination. This is a routine maneuver for SeaLaunch missions. We're now waiting for word of spacecraft acquisition, our final milestone event of this mission. Operators at the Hartebeestok ground station near Johannesburg, South Africa, are tracking this mission to acquire the first signals from the Galaxy 19 satellite. The Hartebeestok facility is a primary tracking station used in transfer orbital support services missions. This teleport supports in-orbit testing of various payloads. The personnel track radio frequency transmissions from spacecraft, such as data about the spacecraft's general health, temperature, acceleration, roll rate, and so forth. The team in the Launch Control Center is monitoring communications for word of spacecraft acquisition, and we anticipate that Space Systems Loral will be confirming this event within the next few minutes. Galaxy 19 is now coasting in its transfer orbit that at its apogee is about 22,140 miles, or about 35,600 kilometers above the Earth. Once a signal from the Galaxy 19 spacecraft is acquired, operators will take control of the spacecraft using onboard thrusters and their onboard attitude control system, as Terry Bolin was describing to us earlier. They will command the spacecraft to begin preparations for testing and moving to its final orbit. And they'll also initiate the activities required for solar panel deployment. And now we're looking at an artist's concept of what this deployment would look like in orbit. And as you can see by our message scrolling across the bottom of the screen, we're anticipating word of spacecraft acquisition at any time.
MD, this is SMM on channel 1.
Go ahead, sir.
The Intelsat ground station at HBK, which is primary, has acquired the
Book the
Galaxy
flight
19
is
spacecraft at 10:18 UTC.
Roger, congratulations.
Наземная станция приняла сигнал от космического аппарата.
And there it is. That's the word. We have acquisition of the Galaxy 19 satellite. We have mission success for Galaxy 19. Very exciting moment. And this achievement marks the 27th successful mission for SeaLaunch, and I want to be the first to congratulate Intelsat on their Galaxy 19 success. This satellite is now transmitting its first signals from orbit, and I also want to congratulate Space Systems Loral, the builders of the Galaxy 19 spacecraft. And we're now looking at a gathering of our guests and employees here in Long Beach, California, celebrating our mission success at about 3:45 in the morning here now. Shell Carlson, president of SeaLaunch, will be leaving the operations center just next door, and he'll be coming in to address this gathering. And we'll be right back with Shell's comments and our mission wrap-up, so don't go away. And we're back to our live coverage of the Galaxy 19 mission, and we're in a room where people have been partying, and now they're waiting to hear from Shell Carlson, who is now at our podium. Shell, what do you have to tell us?
It's hard to top that introduction, Paula. Another fantastic launch. In the Ops Center, I don't know if you guys could see it, but it's what we call a very boring launch, which is very good. Everything was right on target. We have fantastic injection results, and I'm going to run them for you. Our perigee was 2,810, which was 0.3, which was plus 0.3 kilometers. Our apogee was 35,644.1 kilometer, which was plus 8.1. So another bullseye for SeaLaunch, our fifth of the year. Of course, I would like to thank Intelsat and their continued trust and belief in the SeaLaunch system. This was our 8th launch for Intelsat. It's really been a cornerstone launch customer of SeaLaunch. We've been very, very happy. It was also our 9th Loral launch. Been very happy with that and worked very good with this with their system. I'd also like to thank the entire team at Sea, our partners, Aker, Boeing, Energia, Yuzhny, and Yuzhmash. Without their hard work at Sea, in the factories, this would never have been possible. Our 29th launch, our 5th this year, and it's been a great year for SeaLaunch in 2008, and there's many great years to come. So with that, I know that we're running late tonight, so I'm going to introduce a dear friend of mine and a strong supporter of the SeaLaunch program, Mr. Ken Lee of Intelsat.
Thank you so much, Shell. In this line of business, as Shell mentioned, boring is good, and it was excellent today. So I would like to thank SeaLaunch, first of all. And I was here 4 months ago, and just like today, it was another flawless mission. And so this was our number 8 since year 2000. So we had a long relationship, and we hope to continue that relationship for many, many more years to come. Galaxy 19 will be located at 97 degrees west, just over US, and it's going to be joining other 16 satellites in our fleet in most coveted orbital neighborhood in the US. This spacecraft, once in orbit, will be hosting the largest international video programming platform in North America, so it's very important for us. And I would like to thank our customers, of course. Without them, I won't be here, Shell won't be here, we will not be here. So we thank them all their support. And of course, we like to thank Space Systems Loral, who manufacture our spacecraft. And we expect to see the spacecraft working flawlessly for over 20 years. So thank you so much for that. And I would also like to thank our team in Palo Alto. They've been working night and day to make sure that the spacecraft is built to our specs and into perfection. And we expect nothing but perfection from our partners, and our team make sure that that happens. And of course, I would like to especially thank Minda Guru, who's in the Pacific Ocean right now. Hopefully he'll get a long-deserved rest at this point. After today, we are looking forward to launching another 5 satellites over the next 3 years. And of course, SeaLaunch will be a major part of that endeavor. And in closing, I would like to thank you for coming. And again, I would like to thank SeaLaunch for excellent, excellent work. Thank you.
Thank you, Ken. With that, I would like to introduce Chris Hober from Space Systems Loral. Again, this was our 9th satellite launch by Loral, and we've had a great working relationship with them. So, Chris.
Well, while you guys were partying here for the last 1 hour and 3 minutes,
a very routine launch was taking place. And I just want to say that I know, and I think everybody in this room knows, that routine happens because of hard work. So it's the hard work that's gone on in the last several years on all sides, from Intelsat, from Loral, and from SeaLaunch that made this happen. Shell said that this was the 9th launch that we've had with you guys. It's also the 43rd satellite that we've built for Intelsat. And I'm older than most of you, so it's actually my 57th satellite for Intelsat. I don't know if you knew that, Ken. So after that kind of experience, things do become routine. But again, it's due to the hard work of everybody in this room, and I'd like to thank you very much for that work. Thanks.
Thank you, Chris. We, of course, are hoping for many more launches, as Ken said, from Intelsat and also from Loral. In addition to the people I already thanked, I also would like to thank a couple of our suppliers, Barbara Moss and KBTM. They do a lot of hard work, too, and without their support, none of this would have been possible either. So with that, it's been a long evening, but it's a great evening. We've had 5 launches this year, all of them flawlessly executed. We've shown that our launch tempo can be the best in the world, and we do it time out and time in, and this was our 29th mission. We're looking forward to a good year next year, and we're going to look forward to many good announcements coming out of SeaLaunch after this launch, and the future is bright, especially when we perform like this, and this is thanks to all the hard work again from all of the SeaLaunch team, all the Boeing team, all the Yuzhnoye team, Yuzhmash team, Energia team, and everyone else that's supporting us throughout the world. So thanks to you. Have a good night, and I'm sending it back to you, Paula. Thank you.
Thank you, Shell. It was indeed a beautiful mission. To recap this morning's events, a 3-stage Zenit 3SL launch vehicle lifted off from the Odyssey launch platform, positioned on the equator in the Pacific Ocean, at 2:28 a.m. Pacific Daylight Time. The rocket successfully delivered the Galaxy 19 satellite to geosynchronous transfer orbit. Operators at the Hartebeestok tracking station in South Africa acquired the first signal from the satellite, marking this mission a complete success. This concludes our live coverage of the launch of Galaxy 19. I'd like to thank our teammates at sea and here at home port, and the families who support us. And thanks to our partners and suppliers around the world for their contributions to this mission. On behalf of all of us at SeaLaunch, I want to extend our thanks to all of our viewers for joining us for today's launch coverage and another successful mission for SeaLaunch. SeaLaunch continues to build a legacy, one successful mission, one satisfied customer at a time.